Hi, this is Calculus 12, Chapter 5.1. We're going to be looking at estimating area under the curve. And this is a bit of a misnomer. We're actually doing area between the curve and the x-axis. Okay, so if we happen to go under the x-axis, we're doing the area between the curve and the x-axis. And recall that area is always positive. If we have a velocity time graph, we can calculate the distance traveled by calculating the area under the curve. So for example, calculate the distance traveled between 0 and 4 seconds. So we know the formula for d in physics is velocity times time, and we have 3 meters per second times 4 seconds, that's 12 meters. The seconds cancel out, the meter stays. And if we're calculating the area of this rectangle, it's still length times width. And we have 3 meters per second times 4 seconds. And again, that's 12 meters. Let's look at the next problem. Calculate the distance traveled between 0 and 4 seconds. We have a velocity time graph again. We have a slope of 1 meters per second squared. And the formula is d equals 1/2 at, that should be a squared. And that's for when the initial velocity is 0. So we have 1/2, a is 1, and t squared, that's 4 seconds. And if we use the units here, this is second squared. We have second squared in the denominators, and we're left with 8 meters. So let's look at it in terms of area. This is a triangle. So we have 1/2 base times height. So we have 1/2, the base is 4 seconds. And the height is 4 meters per second. Again, the seconds cancel out. We have 1/2 of 16, so this is 8 meters. So we can see there's some correlation between the area and the physics formula. The area and the physics formula. So what happens if the velocity is a curve? We can also estimate, and we'll use this with finite sums. So the velocity curve is 1/4 t squared plus 2. We can overestimate by using the blue rectangle. So the actual area is under the red line, and we're overestimating by this area because this is not part of the actual distance. So we're overestimating in this case. Okay, we're overestimating because the right endpoint is higher than the average value. If we had a decreasing function, the right endpoint would be an underestimate. And if we use the left rectangular approximation method, this one is an underestimate because this rectangle is smaller than the area under the curve. So let's do some calculations. This is 4 times 6, and we get 24 meters. This is 4 times 2, and we get 8 meters. And we can get something in between using the middle value. This is 3 meters per second, so we get 12 meters. Right rectangular approximation method, left rectangular approximation method, and middle rectangular approximation method. That's this. Okay, these are the official formulas for our rectangular approximation methods. It's taking the function at a certain value, the left values, and multiplying it by the width. Here we're taking the middle value because we're adding w over 2 and multiplying by the width. Here we're taking the right values, multiplying by the width. And we're partitioning it into n partitions, so we're summing up all the finite sums. The width is defined as b minus a over n. So here we have b, and here we have a, and in this case, we're just using one partition. On my website, you'll find the key codes on how to enter this program. If you're really having trouble, you can come see me and I'll download it onto your calculator for you. Okay, so let's test out this program. You'll need to enter the function first. So we're entering the same function that we just did in the previous example, 0.25 x squared plus 2. That's our function. Second quit. We press program, and it's on RAM, so we don't have to scroll, but you can scroll like this. And press execute, and press execute again. We only have one partition, and we're starting at 0, and we're ending at 4. And that's our results. Okay, so our results came out exactly the same. LRAM was 8, MRAM was 12, and RRAM was 24. Okay, let's take a look at another example. Find the area under the curve for y equals x squared in the interval 0 to 4 with partitions of 4, 8, 16, and 32. So let's load this up. We need to change the function. Clear, x squared. Second quit. And the program was already running, so I just have to press enter one more time. And partitions, 4, and we're going from 0 to 4. Okay, so we end up with these values here. Just run it again, enter. Enter one more time. 8, 0, and 4. Okay, so we have 8, n equals 8, 17.5, 21.25, 25.5. Now we're going to run with n equals 16. And still 0 and 4. 19.375, 21.3125, 23.375, and n with 32. Okay, we have 20.34375, 21.328, 125, 22.34375. Okay, we want to notice patterns. Math becomes easier when we know patterns, because then we can generalize. Here we're going 14, 17 and a half, 19 and a bit, 20 and a bit. Here we're going 30, 25 and a half, 23 and a bit, 22 and a bit. Here we're at 21, 21 and a bit, 21 and a bit more, 21 and a bit more still. So it looks like we're converging on this answer. And the actual answer we can do this on our calculator. Okay, this is what you need to set the window to. And I'm just going to graph this. Oops, I need to finish this off and graph this. Okay, that's not the window. We need to set it -1, 5, -1, and 20. Okay, and you need to press second trace, and we're doing 7. This is the integral function. 0. You don't need to use the cursors if you know the exact values. You can just type in the exact values. And 4. And we have 21 1/3. Okay, and you can see that this value is getting close to 21 1/3. So you should try this next one on your own. So pause it right now, try it on your own, and then you can check your answer. Once you've done it, continue the video. So negative 0.5 times x minus 2 squared plus 5. And we're going to graph that. And we're going to find out the exact value first. So second calc, 7, and we're going from 0 to 5. Okay, so the answer is 19 1/6. Let's run the program. Second quit, enter. I want 8 partitions, and we're going from 0 to 5. Grab a screenshot. And again, 64, 0, and 5. So notice that when we're doing more partitions, it runs slower. Okay, now when we run 512, it's going to take some time. If you have a TI-84, you're lucky. It's going to run a lot faster. Okay, you've seen how long this is going to take. So I'm going to speed the video up so you don't have to wait through this. Okay, and what we're trying to do is see patterns. Again, we're converging to one value, and that's this value. So the middle RAM gets very close at 512 partitions. Even the LRAM and the RRAM are still getting close at 512. So the big idea is
this is important.
The area is more accurate as n gets large, and MRAM is generally the better estimate. Okay, in science, we do measurements. We take a certain amount of data. We don't have unlimited data, and we'll have a table of data. We still have the same formulas. And here are our t-values. And this is our f of t. This is our function value. Okay, so if we're doing LRAM, we take all but the last point. So we're doing F0 plus F10 plus F20 all the way up to F110. And we're multiplying by the width. We get the width by subtracting. So W equals 10. We subtract 2 consecutive points. So we get 10 times, and I'll just show you some of the calculations. So 0 plus 44 plus 15 plus 35 plus ... plus 22 plus 35 plus 44 plus 30. And we stop it there. And this is 10 times 349. So the answer is 3,490 feet. Please notice your units. Feet per second times second. The seconds cancel out and we're left with feet. Okay, we can do the same thing for RRAM. However, if we already know LRAM, we just have to add f of 120 and subtract f of 0. So we're adding this data point and we're subtracting this data point. So 3490 plus 10 times 35 minus 0. That's 3490 plus 350. And we have 3,840 feet. Again, MRAM would have to average these two, but MRAM is just the same as LRAM plus RRAM divided by 2. So we have 3490 plus 3840 all divided by 2, and we get 3665 feet. Okay, taking a look at the table, we have 13 values. That means we have 12 partitions. So we always have one less partition than the number of values. N equals 12. Okay. We don't want to do this by hand. We want to use our calculator. Please ignore these two columns. There's just leftover data from some other work. So let's look at doing this on the calculator. Okay, we need to press Stat and then Edit. And now we're showing the list. So just enter them one by one. 0, 44, 15, 35, 30, 44, 35, 15, 22, 35, 44, 30, 35. Okay, this says 13. We have 13 values, so I didn't miss anything. Be careful entering this list, otherwise you'll get the wrong answer and you won't know why. So it's always good to scroll through and double check your values. Now we can quit. And we're going to run the program. So program, this is called RAM-L, not left RAM. RAM list is what it stands for. Okay, all we have to do is enter the width because it's already getting the values from the list. And we've got exactly the same values as we calculated. And that completes this lesson.